south and north grid are interconnecting. Thus, if suppose south grid fails, frequency will change. See, the answer for Rahul Kumar question is south grid and north grid, why both are interconnected recently in power system is previously north grid is north side, south is Kanyakumari side, north is Kashmir side. Distance is long. I told power system is having 5 regions: south region, north region, central region, east region, northeast region. North region, central region, northeast region, these 3 are fails. At the time there is no supply to the major city like Delhi. Delhi is one of the capital city and one of the major metropolitan city in India. There is no connection to north region from any one region. In order to maintain supply for the major cities like metropolitan cities, south region is not interconnected to north region. Right now, south region is connected to north region. If north region is fails power, there is arrangement with the help of isolators. Automatically power grid employees are taking care about that. As power grid employees are taking care about that, immediately they will isolate the south region from the north region, because always operation going on in front of the engineers. North region fails, south region will supply power temporarily to major cities like metropolitan cities in the north area. Similarly, south region fails, north region also supplying power to south region. For helping, mutual helping, just we are interconnected. If south region fails, north region also fails, means definitely it is disadvantage to power system. We are having isolators. Whenever frequency problem arising here, automatically this grid will be isolated with the help of power electronic equipments which will be operating in the system, power grid system. That you can come and you can see in practical, you can understand that. Therefore, that we can isolate it. Coming to Bharat Dehradur's question, why no load capacitance dominating and at load inductance dominating? The question is, Bharat question is from Dehradun. Inductance is dominating under full load condition, capacitance dominating under no load condition. Why, sir? Why, sir? That will be discussed in fault analysis. Reason, there is a depth analysis or else voltage control topic. There is 2 topics, one is fault analysis, other is voltage control. If I am going depth analysis of these 2, it takes more time. And one more thing, without basics, I have to explain all those things. As right now, we have to remember like this. In voltage control and fault analysis, I will give very clear analysis in depth to understand why inductance dominating, why capacitance dominating under full load and no load conditions respectively. Okay, friends? Right now, we will continue. Okay. See, sending end parameters is represented in terms of receiving end parameters by using ABCD. We know that Vs is equal to what is the formula? AVR plus BIR. Is is equal to CVR plus DIR. First, no load operation. Reason, there is two effects. One is open circuit effect, other is short circuit effect. Coming to open circuit effect. Open circuit. What is the meaning of open circuit? Load is becoming open. Load is becoming open. A, B, C, D. When load is open, voltage VR becoming VR naught. Voltage maximum in open circuit, VR is equal to VR naught, which is no load receiving end voltage, maximum voltage. Current IR becoming 0. Current IR becoming 0. Substitute these 2 values in these equations. What is the first equation? Vs equal to A into VR becoming VR naught plus B into IR becoming 0. Therefore, Vs equal to A into VR naught. From this, A equal to Vs by VR naught. See, numerator is voltage, denominator is voltage. Voltage by voltage is unitless. Voltage by voltage is unitless. Next, second equation. Is equal to C into VR naught, because of VR is VR naught, plus D into IR is 0. Therefore, from this C is equal to Is by VR 0. Current by voltage. Voltage by current is impedance. Current by voltage is admittance. Admittance represented by Y. But which admittance it is? Open circuit or short circuit? Open circuit. Admittance is open circuit admittance, which is OC means open circuit admittance. A is unitless. C is open circuit admittance. Units are mho. Ohms for resistance or impedance, whereas mho for conductance or admittance, right? Unit of A is unitless, unit of C is mhos, right? And one more thing from this equation, one important formula for gate exam is VR naught is equal to, what is VR naught from this equation? Vs by A. VR naught equal to Vs by A. Now only explain regulation formula. What is regulation formula? Percentage regulation is no load receiving end voltage VR naught minus full load receiving end voltage VR upon VR into 100. What is VR naught from that equation? Vs upon A minus VR by VR into 100. VR into 100. This is one of the important formula. 2 times based on this formula gate questions are came. That is Vs by A minus VR by VR into 100. Right? These are the units of A and C values from open circuit effect. Right? Right now I will apply short circuit effect. Right now I will apply short circuit effect. See, voltage is Vs, current Is. A, B, C, D. Receiving end is short circuited. Receiving end is short circuited. This is Isc. Current is Isc. What about voltage? VR becoming 0. IR is nothing but Isc, or simply IR. Current is IR. Right now I will apply these values in ABCD parameter equations. Vs is equal to A VR. What is VR? 0 plus B into IR. B into IR. From this, what is Vs equal to? B IR. B becoming Vs by IR. Voltage by current is unitless or units? Units, which is ohms. Volts by current is ohms, which is impedance. Which impedance it is? Short circuit impedance. Which impedance it is? Short circuit impedance. Next, current equation Is equal to CVR. What is VR? 0 plus DIR. From this, D becoming Is by IR. Current by current is also unitless. Current by current is also unitless. Therefore, from all these results, what you understand is A and D both are unitless. A and D both are unitless. B is short circuit impedance. B is short circuit impedance. What about C is open circuit admittance. These are the units of which is in ohms, which is in mhos. These are the units of ABCD parameters. Let us concentrate. One more results I have to explain. The results of short circuit you understand. The results of open circuit you understand. These are the results of short circuit, open circuit effect. These are the results of open circuit effect. Let us divide these two equations. One is A, other is C. One is A, other is C. A by C. What is A value? Vs upon VR naught divided by, what is C value? Is upon VR naught. VR naught cancel out. Therefore, A by C equal to Vs by Is. It is the result of open circuit effect or short circuit effect? Open circuit effect. I hope you understand this. Next. Here, B value knows, D value knows. These are the two values from the short circuit. That is ratio of those two. B upon D. What is B? Vs upon IR upon Is by IR. IR cancel out. B by D equal to Vs by Is. This is the result from short circuit effect or open circuit effect? Short circuit effect. Now, transmission line is a combination of both open circuit effect as well as short circuit effect. Therefore, we have to include both the effects. 1 into 2. 1 into 2. What the right side of first equation and second equation? Vs into Is, Vs into Is becoming Vs by Is square equal to left side is A by C, here B by D. Can I say AB by CD? See, one is open circuit result, 2 is short circuit result. Transmission line is a combination of open circuit as well as short circuit result. Therefore, the combination of open circuit and short circuit effect is called as characteristic impedance. What is the name of this impedance? Characteristic impedance. Voltage by current is impedance. Therefore, Vs by S is impedance Z, that is Zc square equal to AB by CD. Zc square equal to AB by CD. From this characteristic impedance, Zc is equal to under root AB by CD. We know that in network analysis you studied, if ABCD parameters, if system is symmetrical, what is the condition for symmetry? A becomes D. In network analysis you studied, symmetry condition is A becomes D. Whenever A becomes D, what is Zc becoming? Square root of B by C. Zc becoming square root of B by C. Now, because A and D both are cancelled out, A and D both are equal, it is cancelled out for symmetry condition. But what is B? B is nothing but already written. What is B? ZSC, short circuit impedance. C is nothing but open circuit impedance. This is another formula. First formula, second formula, third formula. One more formula, Zc is equal to square root of ZSC. What is 1 by Y? 1 by impedance is already you know network analysis, impedance. 1 by Y is Z, which is, which Y? Open circuit, that's why 1 by YOC is 1 ZOC. Now can I say, characteristic impedance of transmission line is combination of short circuit effect as well as open circuit effect. Combination of short circuit effect as well as open circuit effect. And one more thing, from this formula, inductive reactance. YOC means conductance plus capacitive susceptance. In parallel, capacitance element dominating, in series inductance element dominating. That already you studied in network analysis. As we know that in transmission line, R is very less than JXL and conductance is also very less than JBC. Right? Therefore, from that what I can write is Zc is equal to under root R is negligible. It can be written as only JXL. G is negligible. It can be written as only JBC. J cancel out. We know that XL is equal to omega L. XL equal to omega L. What is BC? Capacitive susceptance. What is susceptance formula? 1 by reactance. That is BC. Substitute this BC value and XL value here. What is XL becoming? Omega L. BC becoming omega C. Therefore, characteristic impedance Zc is equal to, the formula is under root L by C. Under root L by C. Practically, the value is designed as 400 ohms for transmission line. The Zc value for overhead transmission line. What is OHTL? Overhead transmission line is 400 ohms. For underground cable also same formula, that is square root of L by C, which is 40 ohms for UC. UC means underground cables. We will discuss in overhead lines and underground cables why the impedance are changes. What effect will be the dominating in overhead lines? What effect is dominating in underground cable at the time of comparisons in cables, right? These are the characteristic impedance of the overhead line as well as underground cable. Characteristic impedance Zc depends only on inductance of the line as well as capacitance of the line. It is independent on remaining any parameter. It depends only on two parameters. What are the two parameters? One is inductance effect, other is capacitance effect, right? Now question is, sometimes questions are asking generally like this. Sometimes generally questions are like this. Length of the line, length of transmission line 100 kilometers for that characteristic impedance is 400 ohms. If length of the line is 200 kilometers, length is increases or increases from 100 to 200 kilometer, then characteristic impedance is, answer same. Reason, characteristic impedance is depends only on inductance and capacitance but not length of the line. That's the reason why answer is 400 ohms. I hope is it clear, right? It is independent on length of the line. Next question is, frequency is 50 hertz, characteristic impedance is 400 ohms. If frequency rises to 100 hertz, frequency is raised to 100 hertz, characteristic impedance also remains same. It is independent on frequency also. Can I say ZC is independent on frequency and length of the line and it depends only on inductance and capacitance of the line. Depends only on inductance and capacitance of the line, independent on frequency and length of the line. I hope you understand, right? So these basics will helpful to understand short, medium, long lines. See, what is my aim right now is, once you are understanding short transmission line behavior, medium transmission line behavior, long transmission behavior, we will apply all these behaviors in stability, so that stability topic will be complete. Most of the questions are coming from stability area only, right? We have so many shortcuts in each and every topic. We will understand each and everything, right? Now, concept number one is short transmission line. Concept number one is short transmission line. Already we understand in the table, short transmission line will have only two elements, R and L. In this line, capacitance is approximate to reason 0. Reason, length of the line is less. For simple analysis, capacity is replaced as 0 in short line. Therefore, alternator is connected to bus bar. The bus bar is connected to transmission line. Transmission line is right now is short transmission line, which is combination of only R and L. Capacity is 0 in short transmission line. It is R, it is JXL. R plus JXL is Z. It is sending end or receiving end? Sending end, VS, IS. Voltage at the receiving end, VR, IR. What is the angle at the sending end? Delta. What is the angle at the receiving end? 0. And source voltage E. Angle at the alternator side also delta. Now it is sending end side is source side, therefore voltage is Vs, current Is. Now transmission line will have two elements, R and JXL. Combination of R plus JXL is simply I am writing Z, and load side is VR and IR. VR and IR. Now this is the short transmission line electrical network. Short transmission line electrical network. Now which is becoming 0? Current becoming 0. As current becoming 0, substitute in the equation. Vs equal to A VR naught plus B into IR is 0. From this, what is A? Vs by VR naught. VR naught and Vs both are same. Therefore, value of A is 1. Short transmission line A value is 1. Next, current Is equal to, what is the formula? C into VR naught plus D into I is 0. From this, C is equal to Is by VR naught. As IR becomes 0, definitely Is also becoming 0. 0 by anything, 0. That means C means shunt element. Shunt element means admittance. There is no shunt element here, that's why C becomes 0. I hope, are you getting my points? Based on this, I will develop shortcuts. There is no shunt element, that's why C becomes 0. But A value is how much? 1. This is open circuit result. Next, I have to make short circuit result. Vs, current Is, impedance is Z, short circuit, current present, but voltage VR becoming 0. Substitute in the above equations. Vs equal to A into 0 plus B into IR. From this, B becoming Vs by IR. If you check here, it is 0. B becomes Vs by IR. Vs is there, IR is there. Therefore, it is Z. Voltage by current is Z. Next, Is equal to C into VR, 0. It becoming 0 plus D into IR. From this, D becoming Is by IR. It is 0. D becoming Is by IR. Tell me, both are in series or parallel? Is and IR both are in series. Therefore, this value also 1. Therefore, short transmission line ABCD parameters are cleared right now. Short transmission line electrical network is series element, only Z. It is sending end side. It is receiving end side. Z, it is sending end side. This is receiving end side. Right? For this network, what is ABCD parameters we calculated is A, B, C, D. What is A value, friends? We got is 1. B is Z. C becomes 0. D becomes 1. A and D both are 1. A equal to D equal to 1. Already now only explained. A becomes D. Symmetrical condition or unsymmetrical condition? Symmetrical. What is symmetrical exactly? Understanding from the network is, if you look from source end, the Z is visible. Similarly, if you look from load end, only Z is visible. If you look for either input terminals or out, don't look from top terminal and bottom terminal. Reason, it is not input and output. We have to look only either output terminals or else input terminals. By looking input terminal, Z is visible. By looking from output terminal, Z is visible. Therefore, network is symmetrical. That's why A and D become both are same. That is 1. Next, B becoming Z. B is impedance Z. C becomes 0. Why C is absent? Reason, there is no shunt element. If you check reciprocity condition, what is the condition for reciprocity in ABCD parameters? Already you know in network analysis. Condition for reciprocity in network analysis already you studied. AD minus BC must be, we have to get 1. What is the value of A? 1. What is the value of D? 1. B value Z. C value 0. Now 1 into 1, 1. Z into 0, 0. 1 minus 0, 1. Therefore, this is satisfying reciprocity condition also. Right? It is satisfy reciprocity condition. Therefore, short transmission line model is symmetrical model as well as reciprocal model. Symmetrical model as well as reciprocal model. Based on these shortcuts, right now we will complete the derivations for medium line and short line. Let us concentrate right now. For this element, it is Z. Z means series element, same element. What is A? 1. What is D? 1. Reason, from this side, only one, which element is appearing? Z. That's why symmetrical A and D is 1, 1. It is series element, that's why B present. B is a series element. There is no shunt element, that's why C0. Same shortcut can I apply for this diagram. In this diagram right now I am taking Y. Y is shunt element, admittance, whereas Z is series element. If you look from this side, which is visible? Y is visible. Therefore, A become 1, D become 1. Reason system symmetrical. What about B? 0. Reason there is no series element. What about C? Y. Reason there is a shunt element. These are the ABCD parameters for Z and that means for this diagram and this for diagram. Already you understand these ABCD parameters in network analysis. Anyhow, once again I repeat it for a better understanding, right? Can I proceed right now to medium transmission line? Therefore, short transmission line model is symmetrical model as well as reciprocal model. Therefore, next concept is medium transmission lines. Medium transmission lines. Concentrate. Medium transmission line will have three elements R, L, C. Medium transmission lines will have three elements R, L, C. Based on capacitance location R, L, both are series element. If C is placed at the load end, this is called as load end or receiving end capacitance method. If capacity is placed at the load end, therefore the method is load end or receiving end capacitance method. Next, R, L, if capacity is placed at the source side, it is called as source end or sending end capacitance method. Sending end C method means sending end capacitance method. If capacity is placed at the load side, load end method. If capacity is placed at the source side, it is source end method because Vs, Is this side, Vr, Ir that side. If impedance dividing has two parts, one is R by 2, XL by 2, other is R by 2, XL by 2. Capacity is placed middle. This method is T method. Now capacity is placed in middle by dividing impedance as this side off, that side off. This is source side, that is load side, right? Or sending end side or receiving end side. This is known as T method. Impedance is not dividing, capacitance only dividing. Capacitance of here C by 2, capacitance of here C by 2. This method is pi method. It look like a pi, it look like a T method, right? Therefore, based on shunt capacitance location, medium transmission lines are classified as four models. One is load end or receiving end capacitance model. In that method, capacity is at the load side. Second one is sending end or source end method. In this method, capacity is at the source sending end side. In this is method is T method because capacity is placed in middle of the line. This is pi method because capacity is placed 50% at the source end, 50% at the load end. 50% at the source end, 50% at the load end. Right? Concentrate right now. One by one we will discuss. Medium transmission line. First one is receiving end capacitance method. Receiving end capacitance method. All elements present or not present? Present. R, L, C. Okay. Alternator is connected to bus bar, is connected to transmission line. Right now transmission line consists of three elements. Reason which method it is? Receiving end capacitance method in medium transmission line, RLC. It is VR, current IR, VS, IS. Diagram is VS, current IS, R plus JXL, it is JXL, inductive reactance. JXL is nothing but Z. It is C is nothing but Y. Combination of those two is series element. Already explained Z. Shunt element is replaced by Y. Already in units itself you understand C is nothing but Y. This is load end. VR, IR. Current flowing through capacitor is IC. Charging current. Current flowing through capacitor is known as IC. Now, if you observe carefully, now only explain for series element. This is Z. For this Z, what are the ABCD parameters? 1, Z, 0, 1. Now only explain, just check. It is shunt element. This shunt element, what is ABCD parameter? 1, 0, Y, 1. Here shunt element present, that's why C present, B 0. Here series element present, that's why B present, C 0. But A and D in both the cases are 1, 1. Same concept I am applying right now to understand the ABCD parameters. Vs, current Is. Vs, current Is. It is the sending end side. After sending end, what is the first element? Series element. What is series element? 1, Z, 0, 1. Because Z is series element, A and D are 1, 1, B, Z, C 0. Because there is no shunt element. Next, what is the element? Shunt element. What is the shunt element? 1, 0, Y, 1. Load side is VR, IR. One element, two element. That's why two matrix are written. One side load side is VR, IR. Row and column operation. Now, let us check right now. I hope you understand these concepts. I will erase this. Vs and Is equal to 1 into 1 plus Z into Y. 1 plus YZ. 1 into 0, 0 plus Z into 1, Z. B is Z. 0 into 1, 0 plus 1 into Y. Y. 0 into 0, 0 plus 1 into 1, 1. VR, IR. From this, A equal to 1 plus YZ, B equal to Z, C equal to Y, D equal to 1. A equal to 1 plus YZ, B, Z, C, Y, D 1. From this, if you analyze very clearly, A is not equal to D. Therefore, it is unsymmetrical or symmetrical? Unsymmetrical. Reason, from the source end if you look, which elements are appearing? Z and Y. Across these two, if you are observing, Z and Y is visible. If you are looking from the load end, which is visible? Only Y is visible. Therefore, the network is not a symmetrical network. Next, check for AD minus BC. What is A? 1 plus YZ. What is D? 1 minus. What is B? Z. C is Y. Plus YZ minus YZ cancel out. Therefore, it is 1. Hence, it is reciprocal method. It is a unsymmetrical and reciprocal method. Therefore, receiving end capacitance method is unsymmetrical method as well as reciprocal method. Therefore, this method is practically not useful. Reason, unsymmetrical method. Right? Once you understand this, I can go for next one, that is sending end capacitance method. Next method is sending end capacitance method. In sending end okay. One more small concept right now I have to explain. Please wait some time. In receiving end method, capacity is dominated under no load condition. Now only our friend Bharat Dehradun is asked, what is the question? Sir, why capacity is dominating under no load? Why inductor is dominating under full load? Will be discussed in voltage control concept. Up to that time, please understand. Reason, the topic is you can understand very depth. That is only the topic we will discuss about that points. That's fine. Please up to that point you can concentrate going on by this way. See, under no load condition, capacitance is dominating. No load means load is open. Whenever load is open, current becoming 0. But capacity is placed at the load side or source side, friends? Load side. As capacity is placed at the load side, entire current is flowing through the capacitor. Reason, there is a even though load is becoming open, due to capacitor, current is up to end of the line. Current is up to end of the line. Reason, there is a capacitor at the receiving end. Sometimes in IES and gate level, this type of questions are asking. In which method charging current is up to end of the line? Which method? Receiving end capacitance method. Reason, capacity is at the receiving end side. That's why charging current is up to end of the line. Right? This is the concept. Anyhow, next concept, sending end capacitance method. Next concept is sending end capacitance method. In sending end capacitance method also all elements are present, R, L and C. But location of capacitance will change or remain same? Changes. Reason, capacity is placed at the source end right now. Current flowing through capacity is IC. Capacity is represented by Y or Z? Y, reason front element. Next, remaining two elements are there, R and L. Load end is VR IR. It is R, JXL. Combination of these two is Z. See, voltage Vs, current Is. First shunt element, therefore Y. Current flow into this one, IC. Next series element, it is Z. This is the load. VR, current is IR. VR, current, IR. Once again, same concept. Vs, Is. What is the first element? Shunt element. Shunt element A, 1. B, 0. C, Y, D, 1. Next element is series element. Series element A, 1. B, Z. C, 0. D, 1. Right? Load side is VR, IR. Load side is VR, IR. Once again, matrix operation. Initially, 1 into 1, 1 plus 0 into 0, 0. 1 plus 0, which is 1. Which is 1. Next, 1 into Z plus 0 into 1. Z plus 1, Z only. Satisfied. Next, Y into 1, Y plus 1 into 0, 0. Y plus 0, Y. Okay. Last one, Y into Z plus 1. Therefore, it is 1 plus YZ. Just A and D values are interchanged, but B and C both are same compared to receiving end method. Therefore, A becomes 1, D becomes 1 plus YZ. A becomes 1, D becomes 1 plus YZ. What is B? Z. What is C? Y. Once again, A is not equal to D, therefore unsymmetrical. AD minus BC. What is AD? 1 into 1 plus YZ minus BC, Z into Y. ZY cancel out. Therefore, it once again 1. It is reciprocal. Now, what do you understand? Sending end capacitance method is also unsymmetrical model as well as but reciprocal mode. Unsymmetrical but reciprocal method. If you see from source end, as a observer, if you see from source end, which is visible, friends? Y only visible. If you see from load end, which is visible? Z and Y both are visible. That's why it is unsymmetrical model. Okay. And one more point here is, in order to calculate charging current in the line, we have to do open circuit. Reason capacity is operating under no load condition. Whenever it is no load, current will become 0 in the line. There is no charging current in the line. Reason, there is a capacitor is connected at only source end. Entire current is deviating here. There is no current in the charge. There is no charging current in the transmission line under no load condition. There is two questions. Charging current is up to end of the line because there is a capacitor at the receiving end. That method is receiving end capacitance method. Charging current is not present in the line because entire capacitor is connected at the source end because it is sending end capacitance method. Understand, my dear? Right? Next. Therefore, sending end and receiving end methods both are unsymmetrical models. We will go for T method. Next method is T method. T method, right? I can erase these things. In T method, impedance dividing has two parts, like R by 2, JXL by 2. R by 2 plus JXL by 2 is Z by 2. R by 2, JXL by 2. Capacity is placed at middle. Capacity is nothing but Y. R by 2 plus JXL by 2 is Z by 2. It is VR, current, IR. See, very clearly you can observe here, Vs, current, Is. It is Z by 2. This one is Y. Y can be written as Y by 2 and also Y by 2. y by 2 plus y by 2 if you are connecting y. Next z by 2 vr ir. If you see this diagram, source end, first what is there, now only we understand capacitor is at the far end but not the source side, as it is other end, it is receiving end method. This method is which method? Receiving end method up to now. First capacitor is there, therefore this method is sending end method. First half capacitor is at far end, that's why it is receiving end method. In second half capacitor is first, therefore it is sending end method. Combination of those two will give what method we will see right now. First end is receiving end, second is sending end. Let us concentrate right now. Vs, current Is. First one is Z by 2. Z by 2. Y by 2 plus Y by 2 is Y only. Y by 2 plus Y by 2 is Y. Next Z by 2. Voltage at the receiving end is VR. Current is IR. Current is IR. Let me check. This is which method? T method. It is a combination of receiving end plus sending end. That's why we will discuss receiving end plus sending end method. Combination of receiving end plus sending end method is nothing but T method. Reason, here we are adding Y by 2 plus Y by 2 is Y. Let us concentrate right now on ABCD parameters. Vs, Is. First element is series element. What is the series element? 1. B is Z by 2 right now. Not Z, it is Z by 2. What is C? 0. D 1. Reason, there is no shunt element. Next, shunt element is there. What is the shunt element? A 1, B 0, C Y, D 1. Next, series element there 1, Z by 2, 0, 1. Next, VR, IR. VR, IR. See, you understand this all matrix calculations. Let's multiply these two. 1, Z by 2, 0, 1. 1 into 1 plus 0 into 0, 1. 1 into Z by 2 plus 0 into 1, Z by 2. Y into 1 plus Y into 0, 1 into 0, Y plus 0, Y. Y into Z by 2 plus 1, 1 plus YZ by 2. VR, IR. Next, row and column operation once again. 1 into 1 plus Z by 2 into Y, 1 plus YZ by 2. 1 into Z by 2, Z by 2 plus Z by 2 into this, it becoming Z into 1 plus YZ by 4. 1 into Z by 2 plus Z by 2 into 1 plus YZ by 2. Z into 1 plus YZ by 4. Next, 0 into 1, 0 plus 1 into Y, Y. 0 into Z by 2, 0 plus 1 into that 1, 1 plus YZ by 2. VR, IR. These are the ABCD parameters of T line. Which line? T method. Right now, if I observe, it is ABCD parameter matrix scheme. A and D both are same. A equal to D, which is 1 plus YZ by 2, which is symmetrical or unsymmetrical? Symmetrical model. Which is symmetrical model. Next, check for AD minus BC. What is AD? A is 1 plus YZ by 2. D also 1 plus YZ by 2. Both are multiplied. 1 plus YZ by 2 whole square. Minus BC. Check directly. BC. Y into Z. YZ. Plus Y. Z into, that means Z is multiplied, Y also multiplied. Y square Z square by 4. Let's check right now. 1 square plus B, A square plus B square plus 2AB. A plus B whole square formula. 1 square plus Y square Z square by 4 plus 2 into AB. A is 1. B is y z by 2 minus yz minus y square z square by 4. 2 cancel out, plus yz minus yz. This one cancel out. Therefore, it is 1. Therefore, this network is symmetrical as well as reciprocal network. What is the network? It is symmetrical as well as reciprocal network. I hope all are understanding, right? See, nominal T, this is T method. In this T method, under no load condition means load is becoming open. Whenever load is becoming open, current flowing through the load is 0. But there is a current up to the capacitor, where capacitor is present up to middle. Therefore, charging current present up to middle of the line. In T method, charging current present up to middle of the line. Why up to middle of the line? Because there is a capacitor up to middle of the line. Therefore, in T method, charging current is up to middle of the line. Therefore, it is the T method. I hope you understand. T method is a symmetrical as well as reciprocal method. Can I go for now pi method? Right now I can move for pi method. Right friends? Next, pi method. In pi method also, all elements are present. Vs, Is. %50 of capacitance, it is C by 2. Current is IC1. R plus JXL. It is Z. It is C by 2. Current from this one is IC2. This is receiving end. VR, IR. Now, 50% capacity is connected at source end, remaining 50% connected at load end. Therefore, it is look like a pi method. Let us concentrate right now. Sending end side is source side, Vs, Is. First shunt element is connected, Y by 2. Current IC1. Next, R plus JXL is Z. I am writing it as Z by 2. Z by 2. Next, remaining Z by 2 I am writing in another place. Next, another capacitance is Y by 2. It is also C by 2, Y by 2. That's why this current is IC2. Load end is VR, IR. See, right now towards source capacity is connected. Therefore, it is sending end capacitance method. If you observe from this network from here, capacity or the load side, therefore this method is receiving end capacitance method. Which method is receiving end capacitance method? By combining both sending end plus receiving end, Z by 2 plus Z by 2 becoming Z. Vs, Is. It is Y by 2. IC1. Z by 2 plus Z by 2, Z. It is Y by 2. IC2. This one is VR, IR. It is pi method. Sending end plus receiving end method is nothing but pi method. Whereas receiving end plus sending end is T method, previous case. Right now, ulta. Sending end plus receiving end is nothing but pi method. Z by 2 plus Z by 2 is Z. Right now, I am applying ABCD parameters. Right now, I am applying ABCD. First one is source side. What is source side? Vs, Is equal to. First element is shunt element. Shunt element A1, B0, C is that element. What is that element? Y by 2. D is 1. Next element is series element. What is the series element? A1, BZ, C0, D1. Next element is shunt element. What is the shunt element? 1, 0, Y by 2, 1. Finally, we are IR. Finally, we are IR. Multiply these two. First, 1, 0, y by 2, 1. 1 into 1 plus z into y by 2. 1 plus yz by 2. 1 into 0 plus z into 1, z. 0 into 1 plus 1 into y by 2, y by 2. 0 into 0 plus 1, plus 1. We are IR. Next, 1 into 1 plus yz by 2 into 0. Sorry, plus 0. 1 plus yz by 2. This becomes 0. 1 into z plus 0 into 1, z. Y by 2 into this plus 1 into this. It becoming y into 1 plus yz by 4. Check right now. Y by 2 into this plus 1. This is becoming y into 1 plus yz by 4. Y by 2 into z plus 1. 1 plus yz by 2 is VR IR. VR IR. Now, if you see clearly here, A becomes, D becomes, both are same. A and D is 1 plus yz by 2. What about B? Z. What about C? Y into 1 plus yz by 4. C is equal to y into 1 plus yz by 4. A and D both are equal. It is symmetrical and unsymmetrical. Symmetrical. Just we will see reciprocity. What is reciprocity? AD minus BC must be 1. What is A? 1 plus yz by 2. D also 1 plus yz by 2, which becoming 1 plus yz by 2 whole square. What is B? Z. C? Y into 1 plus yz by 4. We will see right now. A square, 1 square, plus B square, y square, z square by 4, plus 2ab, A is 1, B is yz by 2, minus zy, minus z square, y square by 4, plus 2 cancel out, plus yz, minus yz, this term, therefore, it is 1. Therefore, it is also symmetrical as well as reciprocal method. Now, tell me, among 4 methods, what are the 4 methods? Receiving end method, sending end method, T and pi methods. These two are unsymmetrical methods, but these two are symmetrical methods. T is a combination of receiving end plus sending end, whereas pi is a combination of sending end plus receiving end. To represent these two, we required receiving end plus sending end methods. Out of 4 models, what is the symmetrical model and reciprocal model? T and pi methods, but not sending end method, but not receiving end method. I hope you understand, right? One more thing. Under no load condition, load becoming open, current to the load is 0 by assumption. This capacity is 50% here, y by 2. This capacity also 50%. Assumption, this impedance almost negligible for exact understanding. If Z is there, less current is dividing because it is more. If Z is negligible, 50% current is dividing here according to current division technique. If Z negligible, 50% current is flowing through the another capacitor. Can I say there is a charging current up to end of the line because half of the capacitance at the end of the line. Therefore, how much charging current in the line is 50% magnitude. How much charging current in the line? In the line is 50% magnitude. 50% charging current is deviating here. Reason capacity is off here. Another 50% is traveling in the line up to end. Reason there is a capacitor at the receiving end. Can I say charging current is up to end of the line as it has 50% magnitude, but not 100%. If charging current is up to end of the line is 100%, that means capacitor is totally at receiving end. That is receiving end method. There is no charging current. Capacitor at the source end. Charging current is up to middle. That is T method. Charging current is 50% magnitude in the line. That is pi method. In this way, we have to understand T model, pi model, as well as sending and receiving end model. Now tell me, medium transmission line is having how many models? 4 models. Out of 4 models, which are symmetrical and reciprocal? T and pi method, but not sending end and receiving end method. But those methods are useful in order to create T and pi methods. This is the results. right? Next concept is long transmission line. Long transmission line. So far we can apply KCL, KVL for medium line and short line explained, but long transmission line definitely distributed manner, therefore you have to apply mathematical concept. Vs current, Is, it is circuit breaker or switch, R L C, R L C, R L C, R L, right now this is the load. Load input R L C C L R L C C. Let current flowing in the inductor is I1. This current flowing in the inductor is I2. Voltage across capacitor is V1. Voltage across capacitor V2, V3, I3, and so on. Right? See, receiving end is the reference or sending end is the reference? Always receiving end is the reference. Now only explain why receiving end is reference. Receiving end is reference. Reason, these are known values. Without knowing demand at the receiving end, we cannot generate the power at the sending end. Therefore, receiving end is the reference. Therefore, the length of the line I am assuming from the receiving end to sending end is L kilometers. How many kilometers? L kilometers. We cannot derive derivation for L kilometers. Therefore, from receiving end, I am assuming certain length which is x kilometers at point K. One point K I taken from the receiving end, which is of how many kilometers? X kilometers. How many kilometers? X kilometers. See, receiving end is the reference. Sending end is supplying power from sending end to receiving end. As receiving end is reference, we have to take length of the line is from receiving end to sending end is L kilometers. In practical, we don't know. But L kilometer derivation not possible. Therefore, from receiving end, I taken one point K, which is of x kilometers. Okay, before going to explain, there is a question from our friend, that is Rahul Kumar. Sir, you told short line has higher resistance because of thinner conductor, but suppose bulk amount of power is to be transmitted through short distance, then cross section of area will be increased of the line. Since the line has to carry large amount of current, thus resistance will be reduced, thus increase the efficiency. Please clarify. Sir, you told short line has a high resistance. Okay, short line is high resistance. Reason, area of cross section of conductor is less because of thinner conductor. Okay, but suppose bulk amount of power is to be transmitted to shorter distance, then cross section of area will be increased. Oh, short distance if you are transmitting more amount, then cross section of area will be increased of the line. Since the line has to carry large amount of current, and thus resistance will be reduced. Okay. This increased efficiency, please clarify. Okay, if resistance becoming increased efficiency. Our friend Rahul Kumar is asking question, sir, you told short transmission line area of cross section of conductor is less, definitely resistance more, efficiency is less, I told previously, that is 95%. But if short transmission line, if you want to carry bulk amount of power, area of cross section of increases, sir, in order to calculate bulk amount of power, for that resistance reducing, efficiency increasing. Is it so? He is asking question. Is good question. Let me explain right now. See, First of all, this is generating station, load center. Practically, generating plants are constructed in rural areas. As we are constructing in rural areas, as power plants are constructed in rural areas, that power will be transmitted to very long distances. There is no short line concept in practical, right? Because long distances, definitely power is carrying by long lines. Suppose if you want to carry, okay, practically that is not exist, but ideally we will discuss. Ideally, if you want to transmit more power through short transmission line, as more power we have to transmit short transmission line, definitely it has to carry more inductance, more capacitance. But under full load condition, which is dominating? Full load condition, inductance is dominant. Under full load condition, as inductance is dominant, definitely L value is more. In order to get L value more, reactance must be also more. X is equal to 2 pi FL. L value more, reactance also more. But short transmission line inductance is not that much when compared to long transmission line. Reason, area of cross section of conductor is more. If you are designing area of cross section of conductor is more with forcefully, definitely inductance effect also more. In that case, we can design. If you are designing like that, we can transmit power, a bulk amount of power by short line. But practically, short lines will have less inductance effect. Reason, area of cross section of thinner. Based on that only, we are discussing a short line and long line. As area of cross section is thinner, area of cross section is thinner, definitely reactance also thinner. Therefore, short line is not having more inductance. Long line is only having practically more inductance. That is the reason why. We are not transmitting bulk amount of power by short line. That application is not there practically. We have only long lines. Ideally, we can do, but long lines, short lines we have to design with more inductance. Some insulation problems will come. As distance is less, inductance more means. Is it okay? Right. We will continue this long transmission line derivation